All right, so part 2 of Unit 0, Lesson 3, third page, explore with fractions. Use improper fractions as answers. Be sure to simplify. For more practice with like and unlike denominators, see arithmetic book on those pages. So this is why we needed to know the lowest common denominator. We needed to use multiples sometimes, because fractions can only be added together when the denominators are alike. Okay? Because a quarter plus another quarter gives you 2 quarters. So we're only adding really across the numerators. That's why the denominators have to be correct. So a quarter plus a quarter gives you a half, right? You have 2 quarters, you have a half. You have a quarter of a pizza, another quarter of a pizza, you have a half a pizza. Because we use the divisibility tests and found out they're both even, so 2 goes into both these numbers. Sorry for the long explanation. You probably got a half about half an hour ago, but that's technically what we're doing. We're adding the numerators together, getting a 2, keeping the same denominator, and then reducing the fraction to 1/2. Okay, so we're adding 2 positive numbers and getting a positive number. Now we're going to add 2 negative numbers and get a negative, no matter how it turns out. You look at the denominators, they're both fractions, they both have the same denominator, so this is going to be coming over here like that. And then the one instruction said the absolute value of each of the negative numbers. So 5 plus 1 is 6, so that gives you the negative 6/7. Some people like to add them sort of this way. They do a vertical whichever way you want to do that comes out to be the same way. All right, so here's an equation. We have a lot of negatives: 1 negative, 2 negative, 3 negatives. They're all fractions, but we have all the same denominator. So 3 negatives together is going to give you a bigger negative, and it's going to have a 7 on the bottom. So you can add the numbers at the top: 3 plus 6 plus 2. Let me turn my key here to make sure I'm getting on the right page here. 9 plus 2 is 11. Can I reduce that? Are 11 and 7 prime? Well, they're not even. 3 doesn't go into them. 5 doesn't go into them. Nothing else. So they're both prime. So that's my final answer. Back over here, the 6 is not prime, but the 7 is. So that's my final answer. All right. So negative plus another negative is going to give me a negative. They're both fractions. They both have a denominator of 4. And so that means we're adding the top. We get there. They're both even. Still both even. If you have a 2/1, what's the simplified version? Does it have to be a fraction anymore? If you have a 2/1, you can even put it in your calculator. 2 divided by 1. It's going to give you a whole number 2. Okay, some people got that way back up here. You do not have to show, oops, what'd I forget? That's a negative. All right, so I have a big mess up here. Let me try to. Sorry about that. Back up here when we had negative 8/4, you can put that in your calculator and you get a negative 2. Okay. You don't have to show work by stepping through all these reductions. I would like to see the negative 8/4, and then you can immediately change it into a negative 2. I'm assuming you can put it in your calculator or you reduced it by hand. It doesn't matter to me as long as I see this This part of the negative 8 over 4 is showing your work, and then that translates to a negative 2. Okay? All right, the next one, they're both fractions, they're both positive. I'm going to have a positive answer, but the denominators are not the same. So what is the least common multiple, or the least common denominator of 4 and 8? Well, the 4 does go into the 8, right? So they both can be converted into fractions that are over 8, which means we don't touch that one. But 1/4 is what over 8? Well, 4 times 2 is 8, so 1 times 2 is 2. So an equivalent fraction to 1 over 4 is 2 over 8. Now that I have the denominators the same, I can add across the top, keep the bottom. My final answer is 3 over 8. Okay? So when the denominators are not the same, you need to convert so that they are the same. All right, how about 4 and 7? I'm going to have a positive answer because they're both positive, but 1/4 and 1/7 needs to be converted into something else. We need the lowest common multiple of 4 and 7. Okay? 4 times 2 is 8. 3, when they have no factors in common, you can multiply them together. So 4 times 7 is 28 times 7. So 7 over 28 is the same fraction as 1 over 4. You can turn a 7 into a 28 by multiplying by 4. So we can add the numbers together. 11's a prime number, so it doesn't get reduced. So we're making other fractions. We're making equivalent fractions that have a common denominator, so we can add them together. Okay. This one I didn't make a bunch of multiples for. The reason you're thinking multiples, the 6 and the 8 were, they had a common factor of 2. So I needed to go through and find all the multiples. But when they have no common factor, 7's prime. So if you're doing a 4, you would have had to do 4 times 1, 4 times 2, 4 times 3, 4 times 4, and go all the way up to 4 times 7 to get the same number you get for 7 times 4. That seems like a long way to go. So when you get stuck, just multiply them by each other, and you can always reduce later if you don't get the number you want. Okay? When we were doing 1 over 6 and 1 over 8, you could use 6 times 8 or 48, but then you just have to reduce more at the end. So they'd like you to use, get in the habit of trying to find the least common multiple. Okay. All right. Over here we have fractions. We have 2 negatives. Our final answer is going to be negative. But we have 7 and 21. Can we use, this is how I do this. Step 1, are they the same? They're not the same. Step 2, is one a factor of the other? Is one a factor of the other? Okay, 4 does go into 8, 7 does go into 21, so I can keep the 21. Oops. I wrote it over here. I can keep the 21 because 7 goes into 21 3 times. 3 times, that's 9. So negative 3 over 7 is the same thing as negative 9 over 21 plus a negative 5 over 21 gives you a negative 14 over 21. Can you reduce this? These are kind of big numbers. Let's think about that for a second. I said 11 was prime. How about a 14? What goes into a 14? A 7 goes into a 14. So we know 7 goes into a 21. So negative 2, 3. Got to do that. okay? All right, next one is a 6 and a 9. Sorry, this is getting a little messy here. 6 turns into something over something, and 4 over 9 turns into something over there. Least common multiple of 6 and 9. They have anything in common? 6 doesn't go into 9. Both are divisible by 3, so that means I should do the multiple thing. So let's think of multiples of 6. 6, 12, 3 times 6 is 18, 4 times 6 is 24. Multiples of 9, 9 and 18. Oh, right there. So 18. It's 9 times 2 to get an 18, so 4 times 2 is an 8. 3 times 6 is 18, so 3 times 5 is 15. All right, so my new problem is 15 over 18 plus 8 over 18 gives me 23 over 18. Can I reduce that? Let's see. They're not divisible by 23 is not divisible by 2. It's not divisible by 3 because 2 plus 3 is 5. It's not divisible by 4, and I'm thinking it's a prime number. Okay? Write that down. I'm going to have to erase to make some room here. All right, so this answer was, double check, positive, positive. So that was positive 23 over 18. All right, so let's go over here. All right, fractions galore. My final answer is going to be negative. I have a 16 and a 2. A 2 does go into a 16, so that means I can keep the 21 over 16 and change the 5 over 2 equals something over 16. So 2 times 8, do the 16 divided by 2 is 8, right? 2 times 8 is 16. So that means I need to multiply the 8 times the 5 is 40. That seems a little odd to do, but hang in there. It was a negative, so it's still a negative 40 over 16. See how we had to do that? The 2 needed to be turned into a 16. So 2 times 8 is 16. 5 times 8 is 40. Now I have denominators that are the same. They're both negative. My final answer is negative. I add these two together and I get a 61 over 16. 61 is a prime number. It's not even. It adds up to a 7. It's not divisible by 3 or anything else. If you want to check for like 7s, 11s, 13s, put them in your calculator and give them a try. Okay? All right, so we know how to add and subtract. Actually, add positive and negative fractions. Okay, this one, add 2 or more real numbers with different signs. All right, so we had negatives plus negatives equal a bigger negative. Well, what happens when the signs don't match? Okay, so again, we have 2 sets of instructions. Your book does both of them. Pick one that you like and stick with it. Let me read through them. This one says to add 2 numbers with different signs, one positive, one negative. Find the difference of their absolute values and give the difference sign of the greater absolute value. I have an example below. Let me read this other one. If the signs don't match, subtract the numbers as if they were positive, then use the sign from the larger number. That means if the larger number was positive, then the answer will be positive. If the larger number is negative, then the answer will be negative. So let's look at an example of those. So if the temperature is negative 4 degrees and it increases by 10 degrees, adds, right? So it was at negative 4, then it goes up 10 degrees. You add them, pretend that negative's not there for a second. So you can go, actually some people go 10 minus 4. However you want to, some people do a visual kind of thing. We're down here at a negative 4, and then we go up 10 to a 6. Okay, there's a 6 difference in the spacing there. So let's try to follow the directions. It says to add two numbers with different signs, positive and negative, find the difference of their absolute values. So that's this one here. So a positive 10 minus minus 4, the absolute value is 6. Put this in your calculator. Negative 4 plus 10 is 6. It's very wordy, but I don't think it's that hard to do. Especially that's what your calculator is for. So 3 minus 10 is a negative 7. If it agrees, 3 drops by. Okay, so we're at 3 degrees, and we drop, this was plus 10, we drop by 10 degrees. Where are we now? We went past 0, right? So we're down here at negative 7. So the absolute value of 10 is 10, minus the absolute value here, that gives you 7. And then the 10 was larger, so you have the negative answer. 3 plus a negative 10 is a negative 7. So I'm not sure how you can visualize that, but that's where the calculator comes in, okay? Make sure you're putting the signs where it needs to go. If I would think of this, number 1 here, as 10 minus 8. 10 minus 8 is 2, but the larger is negative, so this is a negative 2. Then we have a negative and a negative. So I would add the two negatives together. If you'd like to piecemeal them, you don't have to. Negative, I'm getting out my calculator. Oops. Checking my key here. Negative 27, sorry. Minus 138 over, you're adding another negatives, gives you a negative 165 plus 55. So 165 minus it's a negative 110. So you don't need to show me this step if you put them all in your calculator, like especially with these decimals. If you want to line them up, some people add all the negatives together first. So negative 4.043, negative 0.042. You can add them by hand. Nothing says you can't. And then you're adding an 8. So however you want to do this. I like to put it in my calculator all at once, just so I don't make any mistakes. Sorry, working on it. So I'm looking at my key, dropping negatives all over the place. All right, so that should be negative. Think about it. That is, oh, wait. I think I messed that one up. Let me do that again. I think it's important to go back and do a visual check. I have a negative 4 and a negative little tiny fraction. So, but I have a positive 8. It's only logic that my final answer has got to be positive. Okay? So, again, messed up in the calculator. So negative 4, I'm just going to put it all in ones here. So negative 4.041 plus 8 minus 0.042 is a positive 3.17. There we go. Sorry about that. So I know sometimes it gives people anxiety if the teacher's wrong, but I have to tell you, does it make you feel better that nobody's perfect? Try to hang in there with these. And I'm not guaranteeing everything that I'm doing now is perfect either. So if you see a an error that I make, please correct me. Please correct me in class. Please correct me with emails if you'd like, if I didn't catch any errors. And just try to accept the fact they're just going to happen. So, because I don't know about you, but I am not perfect. All right, so I have a big whopper number here, minus two smaller numbers. Let me just check that in the calculator. Yep. All right, did that one twice, so I think we're good on that one. All right, and then a negative plus another negative. Good decimal practice here. Can put the 0 in the front if you want me to. Just make, the important part is that decimal and then negative, okay? All right. All right, page 4. We want to subtract real numbers. Addition and subtraction are closely related. They're called inverse operation because one undoes the other. You can rewrite subtractions as additions to subtract real numbers. Subtracting negative numbers can be thought as a double negative resulting in a positive. We just sort of did that. So say I borrowed $5 from you to buy lunch since I forgot my wallet. Borrowed. Okay, you owe me $5, so my balance sheet has a negative 5. Later, I get my wallet and pay you back the 5 so I can subtract my debt, or a net credit. Subtracting a negative is a positive. So we have negative 5, and then we're subtracting the negative 5, which is the same as adding 5, which is 0, okay, which is now what I owe. We took off or subtracted the debt negative number from the balance sheet. So we do use negative numbers. That was a really complicated way of saying I borrowed $5 from you, then I paid you back, so I owe you nothing. So it was 5, negative 5 plus 5 is 0. So it's the same thing as subtracting a negative 5. So it's double negative. Okay, this is my bottom line for that one. Okay, it's looks something like this. So if you have 3 minus a minus 5, it's a double negative. Like if you're not going to not open the door, that's a double negative, which means you're going to open the door. So this can be written this way. Okay, so double negatives can be turned into, I like to just make one big plus sign. So if you're not going to not do something, you are going to do it. So it's a positive. So this right here is a positive. Feel free to just go right into the problem and change that to a positive. So 7 plus 1 plus 5, 13. All right. Negative, decimal, positive, negative, negative. Change that. And then put them all in your calculator. Let me check this number that I have on my key. It is 4.08. All right. Negative, negative, go right in there and change that. Negative 23 plus 37 is 14. All right. Put that in your calculator. Double that. Now watch, those are commas. That's a comma, that's a decimal. Different things, right? Don't need the commas in your calculator. All right, negative that number. Got that twice when I did it, so I'm pretty sure about that one. All right, that's a big plus. That's a positive result. Okay? All right. How about when we're using fractions? Same thing. Negative negative is a big positive. 1/4 plus 1/4 is 2/4, which is 1/2. Okay? This is a big positive. So a -5 plus 1 is a -4. Okay. All right, 3 negatives together all have the same, it's going to be a negative. 3, oh, wait. Sorry. I'm awake. Right there. That's positive. So not necessarily going to be negative, but let's see. So let's do this. 3 plus 6 is 9. So we have 9 worth of negatives. Plus that. Oh, it's going to be negative. Oh. Let's see. I have a -7 divided by a 7. If you put that in your calculator, what do you get? You get a -1. Remember, the same number over the same number is a 1. So whether it's 12 over that, that's the same. You have 12. Excuse me. You have a pizza with 12 pieces. You have all 12 pieces. You have 12 over 12, and you have a pizza. You don't have nothing. Can I say it that way? So this is going to be a -1 for our final answer. Interesting. I didn't know that was going to come out that way. All right. Oh, what do we do if there's a whole number and a fraction? Remember I said that when I'm adding fractions, I need denominators that are the same. Well, 9 is the same as 9 over 1 minus 3 over 4. So we don't have the same denominators. So I need to have a 4 and a 4. So what is 9 in terms of something over 4? Well, the 1 times the 4 is 4. 9 times 4 is 36. So 36 over the 4 is the same as a whole number 9. Okay? That was a 3. So now I can subtract them and get my answer for that. All right? Let's try that again. So a double negative is a positive. Let me get this other thing out of the way here. This was 33 over 4. All right, so this is a positive, but that 10 needs to be turned into something with an 8 on the bottom. So 1 times 8 is 8. 8 times 8 is 80. It's kind of weird. Hang in there. 83 is kind of a big number, but it's not even, so it's not divisible by 2. It adds to an 11, so it's not divisible by 3. Doesn't end in a 5 or a 0, so put it in your calculator. You'll see it's going to give you a decimal. So that is a reduced fraction right there. Sometimes it's hard to tell, I know. Do your best. On a test, I take off if it's reducible and you didn't reduce it, but not a whole lot. So try your best on those. All right. Oh, okay. 6 and 9. We did before. Do you remember? We did, that comes out to 18 as the lowest common denominator. Okay, so 15 over 6 times 3 times 3 is 45. And it was negative. Don't lose that negative. 5 over 9 turned into something over 18. 9 times 2 is 18. 5 times 2 is 10. So that's a 10. I know I did that fast, but these are what you need to practice. There's more in the book if you need to do some more, or get to the tutor center if this is a hard thing. So make sure you're going to the tutor center or working with someone in your class to make sure you understand how to get common denominators. All right, back to the adding and subtracting thing. We have a negative 45 plus 10. Our final answer is going to be over 18. So let's see, 35. It's going to be a negative 35 over 18. Is that reducible? Not a 2, not a 3, not a 7. Nope. Nope. And that's a typo on the key as well. Make a note of that. That is supposed to be a negative. Okay, sorry about the keys. All right, not going to go up. Last one. Okay, Tim started a bank account with $125. He wrote a check for $34.05. He wrote another check for $73.15. He deposited a paycheck of $215.74. What is his balance now? All right, let me double check the number in the key. 125 minus 3405 minus 73.15 plus 21574. Got the number on the key. All right, there we go.